Hello, everyone. Welcome to the latest GCP Live Meetup. My name is Nick Orlov. I'm a customer engineer at Google, and we have an exciting topic for you today. Corey, you want to introduce yourself?
Yes, I'm Corey Peel, and I'm also a customer engineer, and we have one of my favorite topics today.
Yeah.
Yes, Internet of Things.
Very cool. What are those things? Well, to help us with that, we have Brandon Freitag. Brandon, you want to introduce yourself and kind of talk about what topic we'll be covering?
Absolutely. So my name is Brandon Freitag. I'm also a customer engineer here at Google. We'll be talking about not only Internet of Things today, but we'll be talking about how can you actually take information from them and stream them all the way through a process out to the point where you can actually get some visualization from it.
Yeah, that sounds awesome. I know that a lot of customers are trying to figure out how to take in all the data, how to wrangle that data,
Right.
drive some analytics from it. So absolutely. You want to go ahead and get started?
Yeah, that'd be great.
Cool.
Let me share my screen real quick.
Awesome. There we go.
Coming through?
Yep.
Excellent. All right, so Internet of Things can be a lot of different things, but just for a starting point example, let's think of a car and all the types of different information that you could actually derive from it. I mean, you could think of vibration in it, you could think of the temperature of the inside of the cabin, you could think of the temperature of the outside, you could think of the rotation speed of the engine. But for simplicity, let's just talk about speed. How fast you go, how fast you're accelerating. And that's interesting enough. You might want to know all those things about your car, but where it really starts getting interesting is when you start thinking about, well, what about more than just one? What could you actually start discerning if you could actually start collecting more points of data? And obviously, there are ways that we can do that. If you look at just Google Maps today, you can actually go ahead and see traffic in real time and understand, oh, which direction do I want to go to work or to home? What do I want to avoid? And if you actually take that a step further, well, can you actually use that intelligently? And so could you actually start making predictions? And this is where machine learning would step in. So that is fantastic from a practical standpoint. From an architecture standpoint, when you actually start getting it down into the technology and you start thinking about how do I handle all this data flow, it can get really complex. And companies like Spotify have actually found that as they build out systems, it does get complex. And so what they've chosen to do is they simplify it. And they do that by going ahead and using a managed service. And so to kind of pull this all together, for me, there was a very practical impetus behind the overall thought in terms of, well, why would I want to jump into this? And that was, you know what, our offices were cold and we were trying to figure out, okay, is there something we can do in terms of the airflow? Can we talk to facilities? And well, how would we actually communicate that information? How would we actually see, how cold is it? And, does it warm up during certain times? So if I take the architectural portion of it in terms of how would I scale this out, if I take the specific need in terms of, hey, I want to understand the temperature and I don't want to just understand it at a point in time, but I want to see history, and then extend it in terms of, well, what if I actually wanted to put multiple sensors throughout a building or an area or a region? All of a sudden you get into a very interesting IoT type of discussion on architecture. So the starting point was, well, how in the world would I build something like this? And it's relatively simple. You can use a Raspberry Pi, which is great with sensors, motors, all types of different things. You can build a zillion different things, but very simply, you can take a sensor. And in my case, I picked a BME 280 sensor that measures not only temperature, but humidity, pressure, and hooked it up to the Raspberry Pi, added some scripts to it, and I can go ahead and start collecting data. Now, collecting data is great, but what do I do with that data? And so to extend it, well, I want to store it somewhere. So let's go ahead and push it out, and let's use an architecture like Spotify does, and let's push it into a message queue. So use Google Cloud PubSub, and then once it's in there, I want to consume it. Cloud Functions is a very easy way of triggering off of every time a PubSub message is received to go ahead and take that information, and I want to push it somewhere where I can store it. And I might have a lot of data if I get a lot of sensors, or if I run them for a long period of time. I could be talking about potentially terabytes of information, or if you really go big, petabytes of information. And so a serverless data warehouse would be a great place to do that. And so BigQuery was a natural fit. And then once the information's in there, if I want to actually see my information, how would I do that? And so Data Studio is the logical place for that. So this is kind of the overall architecture in terms of starting from, hey, the office is cold, to how do I actually go ahead and collect all this and visualize it over time. So my goal here was a few things. One is, I can hear something in terms of here's how you would do it, but it's easy to forget. If I actually see it work and see how it's assembled, it's much easier to remember. And so that's what we'll do here today. But actually, to take it a step further, if you actually do it, if you actually build it, you get an understanding for exactly what's going on and how everything works. And so everything I'm going to be presenting today is actually going to end up in a code lab. So if you go to codelabs.developers.google.com, there are lots and lots of practical examples and labs that you can walk through. Within the next couple of weeks, this very specific example should be out there so that you can go ahead and build it yourself. You can touch it, feel it, and hopefully fully understand how you can not only play with Internet of Things, but how to construct an entire data pipeline that really is the foundation for what companies like Spotify use on a daily basis. So let's go ahead and get started with the demo. But before I do that, I am not going to actually use the Raspberry Pi and build the full thing out. That will be in the code lab as far as exactly how to do that. Since we have a limited amount of time, what I did was I actually took a Raspberry Pi and had it stream the data over about a day and a half. And I put that information into a cloud storage bucket. And what we'll do instead of having the Raspberry Pi is we'll go ahead and use Cloud Dataflow to go ahead and reach into that cloud storage bucket, pull it out, and then put it into the rest of the pipeline that we're interested in. So let me go ahead and step on over to my Cloud Console. So if you haven't played with Google Cloud Platform before, just go to cloud.google.com and you can actually sign up for $300 worth of free credit. Lets you go ahead and get started and start playing around. Once you go ahead and have your own console, you can log in like this, and you can go ahead and start using all of the different functionality that Google Cloud provides. And so today, what I've done is I've actually pinned the components that we'll be using up here at top just for easy access. So let's start with, what we'll do is we'll start with where's the data going to go? So we'll start with BigQuery. Then we'll go back and say, well, where do we want to push the data to? And we'll go to PubSub. And then we need to connect those two so the data can flow between them, and we'll create a cloud function to do that. And then once that's all assembled, we'll go back to Dataflow, we'll consume the information that we've pre-stored in a Google Cloud storage bucket, and we'll let that whole process work through before we actually step into Data Studio and build some visualizations. So let's go ahead and go to BigQuery. So here's my project that we have for today, the data pipeline. And we just need to go ahead and create a data set that we can store information in. And so I'll give it a simple name, weather data. I'll choose to have it stored in the United States. Hit OK. And then I actually want a table for that information to be stored in. And so we'll give it a simple name. If I can type, there we go. And to make this easy and quick, I'm going to go ahead and just copy and paste a little bit. I can go over here to edit as text, and I can take the information that I copied, and it essentially goes ahead and instead of having to type all this in individually, here's all the information I'm going to be collecting. So each Raspberry Pi I could assign a unique sensor ID to. I'm capturing the time collected. I can put in the zip code where the Raspberry Pi is at. along with its latitude and longitude, and then here's the weather information that each Raspberry Pi will capture and stream. And we'll go ahead and create the table. All right,
Brandon,
so that's...
I could interrupt you for just a second, because so a question just came to mind.
Sure.
I like how you build out the schema, but obviously all IoT devices are not capturing the same amount of data. So what would you do in a circumstance where maybe you had like a weather IoT a device, and then you had like a car pressure IoT device, and you wanted to kind of find correlations between maybe temperature sensing as well as like tire pressure?
That would be really interesting. As far as you know, obviously we would think of, as it gets colder, probably the tires would run a little bit flat. So potentially what you could do is actually create either a different schema that could capture all that information, or you could create a couple different tables as potentially different ways that you would want to go ahead and capture the information. After that point, if you would actually want to manipulate it, you could use the same tools we're using today, such as Dataflow, to actually go ahead and modify that information, put it in a format that you'd want to run perhaps in a machine learning model.
Cool, cool. And perform table joins and stuff like that. Awesome.
Yep.
Sorry,
cool.
I didn't interrupt, so
No.
go ahead.
Anything else?
No. I'd say go for it. This is awesome.
All right, so we'll step over to PubSub, so we'll have some place for the data to flow into. And all we need to do is we need to create a topic. And going with the theme, we'll go with weather data. And there we go. So both of these things so far have been really simple. We aren't managing any infrastructure. Everything is set up. Everything is redundant. And everything is very, very easy to use. So let's go ahead and we'll jump over to Cloud Functions. And we'll go ahead and create a function. And what this function is going to do is actually take the information from PubSub, and then it's going to push it into BigQuery. So therefore, I will call the name of the function weather PubSub to BigQuery. And I'm going to take that information every time I get data on the PubSub topic. And there's the PubSub topic we just created. And then I can put in some code down here. And so I've gone ahead and just staged that over here so it's easy to put in. And we can talk about this code here in a second. If I can go and get this to scroll down for me. There we go. All right, so I need everything as far as functions is concerned is going to be Node.js. So that's my index.js file. And then I also need my package.json file. And we can talk about these here in a second. But let me get this going. All right. And I'll hit create. And this will take a couple minutes to go ahead and complete, but let me step back to the code real briefly. So all this function is doing, and it's pretty straightforward, is it needs to understand that it's going to use BigQuery. I needed to put in my specific project ID that I'm working with inside of Google Cloud. There's a data set, and this is the BigQuery data set name that we gave when we created the data set overall, and then this is the name of the table. Everything else is just basically receiving JSON, parsing it out, and inserting it into BigQuery.
Makes sense.
All right. And the function is now deployed. So what we can do is we can go ahead and jump to Dataflow. And what I've actually done, let me just step back here just to show you for one quick second. If I go to storage, I've created this storage bucket. The Dataflow pipeline is going to need a temporary place to stage data, so I've pre-created this. And let's go ahead and give the Dataflow a name. Okay. Oops. using caps, and it doesn't like it. Okay. This is probably one of the coolest things I think about Dataflow is you can write your own custom template with your own code. It's all going to be Java code underneath the covers. However, Google has provided templates that do basic Dataflow functions right out of the box. So for example, what we want to do is we want to go ahead and go to Google Cloud Storage, take the text files that we have there, and we want to publish them into PubSub so that our full data pipeline can go ahead and ingest data. So with just by selecting that, it goes ahead and gives me options that are applicable in terms of what I want to do. And so, as I mentioned previously, I have already captured a day and a half worth of sensor data, and I've placed it in a publicly available Google Cloud Storage bucket. And so this is its address. It's Google Storage. That's the name of the bucket. And I've got a bunch of JSON files in there. And what they represent is 5 minutes worth of data for each file.
So since we're making this publicly available, so that means that there's a few people who might want to run through some of those data sets.
Yeah, absolutely. So my thought here is, as I mentioned, a code lab should be coming out here within the next couple of weeks with exact instructions of how to do everything that I'm doing, plus the assembly of the Raspberry Pi itself. And so by offering up this information, if people don't want to actually go through the full assembly of the Raspberry Pi and building their own streaming weather, they could walk through this same demo that you're seeing right now without having to do that. And, hopefully within, 20 to 40 minutes is what I'm seeing for most first-time users to actually step through and absorb exactly what's going on. But people can go ahead and do this on their own.
That's awesome. Yeah, once the code lab gets published, we'll be sure to link that to this video.
Great.
Awesome. All right, make sure that I don't have any spelling errors or anything that it's going to choke on. I think everything looks good, so I'll go ahead and kick this off. And so what's happening at this point in time is Google Cloud Dataflow is going ahead and firing up virtual machines to go ahead and handle all of this. And you can see that the job is running, and it will go ahead and go to the Google Cloud Storage bucket, take all the data that it finds in there, go ahead and run it through the pipeline and start pushing it into PubSub. So while we wait for that, it might be a good time to break. Have any questions? If there's any questions coming in,
yeah,
I'm happy
absolutely.
to answer.
Do you have a question you want to start with? Corey?
Yes. So I want to talk just a little bit about the way you were using the templates with Dataflow, because as you know, those of us who've done some of the Dataflow development by hand, from scratch, we realized there's a lot of reuse available. And so as you were able to go through this example, you were able to leverage a template and make it active, and you're fully connected with the other parts of your architecture immediately. So could you just talk maybe a little bit about some of the other options available when you are defining maybe some of your own reusable templates in addition to what's available from Google out of the box?
Yeah, so let's go back in here and let's just take a quick look at the different options that are available. Right, so we could have skipped our whole kind of PubSub to function pipeline. We could have gone straight to BigQuery. You can pull information out of PubSub and back into a different PubSub topic, perhaps, if you're starting to string different things together. The way that I actually captured the information from Raspberry Pi in the first place was I already had this whole infrastructure stood up and running, and I just added a Dataflow, capturing PubSub and dumping it into a GCS storage bucket. So there's lots and lots of different areas that you can use out of the box. And actually, Google is planning on open sourcing these so that if these very specific examples aren't a perfect fit for you, you can go ahead and when they're fully released, you'll be able to go ahead and download them, modify them, create your own custom templates out of them.
Yeah, that sounds good.
Yeah.
Yes. And then also when you are selecting different options from the development process, so you selected Cloud Functions to actually receive the data, the raw data coming from the Raspberry Pi. You could have also used maybe Dataflow or other options. And so I wanted to see how you started to think about the decision of functions, Node.js versus maybe using Dataflow versus other types of options. Again, we have a lot of interesting ways of tying things together. And clearly what you've picked is extremely fast and efficient in terms of developer efficiency, but wanted to get some of your feedback in terms of how you thought about designing and developing this solution.
Yeah, so I think there's multiple layers to that question. Typically, if you've got a large volume of data that is constantly coming through, Dataflow seems to be more the fit for something like that. Whereas I'm doing something smaller scale, things are coming in, I have a handful of sensors in my house right now. So, a handful of times a minute, and Cloud Functions, I believe the first million invocations are free, and the next million invocations after that are like 40 cents for a million. So extremely cost efficient instead of having to have the virtual machines up and running for Dataflow all the time. So there's definitely that overall look in terms of how much data and what am I trying to do in terms of overall cost balance. But then there's also the practical end in terms of if you're going to be doing Dataflow, the code underneath that primarily today is going to be Java. If you're doing functions today, the code underneath that is going to be Node.js. And so if you have a particular inclination or leaning, it might drive you more towards one or another. So there's definitely some different considerations that come into play.
Great.
Yeah, that's awesome. I've got one more question for you since we're still waiting.
Yep.
So I absolutely love how there's so many different options of approaching this problem. There's so many different ways of solving a puzzle. Could you talk for a second about Cloud IoT Core, one of the offerings that kind of bundles all these services together? So is there a reason why you decided to go more of the build it yourself route rather than the IoT Core?
Yeah, so if I go back to this specific slide, something I find extremely helpful is getting my hands onto things. And so I really wanted to go ahead and dive down into, hey, how does the Google Cloud SDK work? Let's get that working on a Raspberry Pi. Let's, actually see how you can connect, what different types of things that you can do from there. And so I'm publishing directly to PubSub because I can leverage that SDK to do so over TCP/IP. With the IoT Core does a great job in terms of HTTP endpoints or using the MQTT protocol. I wasn't layering on MQTT as of yet, although with Mosquito package, you could definitely do that with Raspberry Pi. So although I've chosen to go ahead and kind of do things this way, our IoT Core offering definitely could fit in and would actually be a very simple expansion of exactly what I've done here in order to go ahead and say, well, let's figure out how IoT Core works. Let's drop it in and, try and keep the same basic data pipeline.
Gotcha. Yeah, that makes sense. It's kind of like when I first had to learn calculus in high school. You learn the manual way of doing everything with the hard equations, and then your teacher gives you a graphing calculator, and you realize, oh my gosh, I could have saved myself half an hour for each of these problems. So That's cool. I like how you build it yourself, find out how all the inner workings work, and then as you would approach scaling the solution out, then you would go with something a little bit more automated like Cloud IoT Core. Cool.
Yep.
Yeah. And then with the SDK, when you were developing with your Raspberry Pi, which items were you enriching in terms of the data being captured? And then which pieces were just raw data coming from the sensors?
Yeah, actually, I didn't enrich anything at all.
Okay.
All I did was each Raspberry Pi within its configuration file, you can specify what zip code, latitude, and longitude, and what the sensor name is. And then everything else is just pulling straight out of the sensor in terms of temperature, humidity, dew point, and pressure.
Oh, great. So you're just pulling all the raw data, and based on the model you set up in BigQuery, you're just loading in the raw data as well. So you didn't have to do any transformation. So that's great. sometimes if you want to, you can layer things on. But it sounds like for your use case, the temperature and humidity were the things you were really after, and playing that over. So,
Yep.
Yeah.
Well, so Dataflow job should be all done. We can actually go ahead and check that by running a quick query.
Okay.
And let's just take the limit off. Okay, so we have just about 3,000 rows of data that came in. That was all stored in Google Cloud Storage. It's run through our full data pipeline, and you can see everything's nicely laid out here. And so in order to actually visualize this information, we can go to Google Data Studio. And so let's create a new data source. And we'll use BigQuery. It'll look up my projects. And we'll go ahead and see if the demo demons are nice to me today. It looks like they're playing a little game at the moment. And since it's spinning, let's go with plan B. And let's jump into a report that I've created that's been running since early December. So this is all streaming in from BigQuery. This is actually live data that's coming in from an IoT sensor. And what I've split up is the 4 different streams of weather data that the sensor has. So you have the temperature, the humidity, the pressure, and the dew point. And, the interesting things to start looking through are, you start thinking of, oh, what was happening when this low came through? Was there a huge storm? Why? You can see the peaks and valleys throughout a day. Obviously, typically sometime mid-afternoon. This is all within a building. So sometime afternoon, typically the building is hitting its peak temperature inside, and sometime in the middle of the night, you're hitting the low. Potentially some extremely cold weather was coming through that depressed the pressure. So this is how you would actually put together an entire data pipeline. So you can go ahead and start doing visualization. Like we mentioned, you can actually plop IoT Core into the middle of this, or you could actually go ahead and once you start collecting a lot of data, you could start thinking about, well, would I want to run a machine learning algorithm off of this? And would I need other inputs to make some valuable insights and use it in some interesting ways?
Awesome. Yeah, that's really, really incredible. Taking in a whole bunch of raw data that's coming in every second, every minute, and being able to abstract it in a way that's a little bit more human readable.
That's right.
That's
yes.
cool.
And then what type of information did you have to share with facilities afterwards? Did you figure out why your building was a lot colder?
Well, it definitely did help in terms of, well, look, it's, low 60s in the morning. We need to, can you guys bump up the airflow a little bit just to make it a little bit warmer and more tolerable? So just definitely having the data in hand is what we were looking for.
Oh, excellent. So you have the data to insight to action and actually doing something with it. So that's great.
Yep.
That is very cool.
Yeah.
Well, we are just about right on time. So Brandon, anything else that you want to add in? Any fun gotchas or lessons learned?
Just walking through it is probably the biggest thing overall. Now, the things you didn't see me do is enable the APIs. So if you actually go through this the first time and you're walking through the code lab, that all will be pointed out. Again, a pitch to the code lab that will be coming so that you guys can actually replicate this yourself. I think it was really valuable from a couple different levels. One is just, this is a pattern that is actually architecturally used many, many times, especially when you need to scale. And then just on the lower level, being able to actually knit individual components together, see how they fit and fit into a solution, I think is extremely valuable.
Man, yeah, that is awesome. Cool. Corey, any last minute words?
Oh, great job. And I hope everyone remembers to go and actually execute those code labs.
Yeah, I'm already going to be buying some Raspberry Pis and trying it out. I'm excited.
Yeah.
Cool. Well, thank you so much, everyone, for joining us. Thank you, Brandon. Really appreciate your time. Please remember to rate and subscribe to the YouTube channel. And until next time, keep searching on. Thanks, everyone.
Thanks.
Bye.
Bye.